Hello, today our topic we're going to talk about standard units in a normal curve. So the essential question is how are units standardized in a normal curve and how does standardization help us compare between data sets? So we've talked last time about the 68, 95, 99.7 rule, and a lot of the normal curves will share common characteristics. They all have a smooth bell shape, and they all have the same size if we measure in units in size of sigma about the mean mu. So changing these units is called standardizing. And to standardize a data point, we subtract the data point from the mean and divide by the standard deviation. The formula is written right here for you, and I'll talk about z in just a minute, but it's the data point minus mean, or mu, divided by the standard deviation. So you can pause this video for just a minute and copy all this information down. And then z. So a lot of times when we standardize these units, we use the variable z, and that's called the z-score. It tells us the number of standard deviations the original measurement is from the mean. The z-score is said to be in standard units. So your first example. For a given population of high school basketball teams, the mean or average points per game is 74 with a standard deviation of 6 points. What is the z-score of a team who scored each of the following points? So again, you have the formula written down in front of you, but it's z equals, and then it's your data point minus the mean divided by S, or sigma, or the standard deviation. I'll write both of them, because that's another way you'll see this formula written. Okay, and S and sigma are the same thing. So what's the z-score of a team who scored 74 points? So 74 points represents your x value. That's your data point that you're observing. Mu is the mean. And it told us up in the question above, the mean points per game is 74. And then the standard deviation is 6. So we're going to substitute these values in to solve for z. And then after we do all of our algebra, we get that this is a z-score of 0. So that means that 74 points is 0 standard deviations away from the mean, which means you're getting exactly the mean. Okay, so what about a team with 84 points? You're going to do the same thing. You're going to use the formula again. You're going to substitute 84 in place of x this time. So x equals 84. Mu, or the mean, equals 74. And your standard deviation equals 6. Oops, I'm sorry, 85, not 84. So 85 minus 74 divided by 6. Which simplifies to 11 divided by 6. Which will get you a value of 1.83. which means that a team that scored 85 points scored 1.83 standard deviations above the mean. And then a team with 65 points, so x equals 65 this time. Mu is still 74, and sigma is still 6. Substitute the values in. Notice how I'm still keeping x up front, or I put x first and then subtract the mean from it. This time we get negative 9 over 6, which becomes negative 1.5. Okay, so that just means this time, yes, we got a negative number, but that means that instead of scoring above the mean, we just scored below. So this is telling us that we scored 1.5 standard deviations below the mean. Last question, same thing, just substitute it all in. X is our observed data point, so that equals 56. We still have a mean of 74, a standard deviation of 6. Just plug it in. So if we get 56 points in a game, then that means we scored 3 standard deviations below the mean. All right. Your classwork questions will be just like this, so give them a try and let me know if you have any questions.